Really is a question, can you program a machine to do it? A couple of other ones are, just because you want to believe that machines can think doesn't mean they can. Just because you want to think machines cannot think doesn't mean that they can't. So you have a problem discussing these things. Does anyone want to start before I start pointing my fingers at people? Nobody wants to volunteer? Lady back there.
Hi. No, I do not believe that computers can think.
Can they hear you over there?
And I challenge anyone to disprove me.
But you give any reasons why? Why do you think?
I don't think a computer can think because it would take a thinking individual to write a program to simulate thinking. I don't think that a computer is capable of creative thought.
You don't think the programs I discussed creative thought, like a checker playing routine, which clearly produced moves that surprised the checker master?
I think the programmer could come up with identify every situation and come up with a move, but I don't think the computer or the program.
But Samuels didn't know how to play checkers, but the program he wrote learned how to play checkers, didn't it?
I don't think so.
Oh. Did you ever learn anything?
Yes.
Was the teacher telling you?
Sure.
Okay, you can't learn either.
I'll accept that.
Okay, yeah, fine. Now we got to go. Good.
I agree with her. I don't believe machines can think.
Would you give me a better argument?
I believe that a computer is limited by its programming, but as programs become more and more complex, that appears to give the illusion of thinking. The example of the checkers program, actually let me step back. We talked about chess programs quite a bit. And when you really look at what a chess program's doing, the machine is analyzing the moves in the board's positions and picking its move based on the best probability of success. Now also the checkers program we talked about, it certainly learned by observing moves and the success of those moves. So what it was doing was really updating its database of information and improving its analytical database and picking a probability of success.
You are different.
I believe so, because we can create something from nothing. I believe that, well, look at Einstein's a perfect example. He came up with a theory of relativity, yet where did he learn that? He had a creative spark that I don't think a machine can have. I think the machine is limited to the data it's programmed with.
But I think we learn the same way that the computer is learning. We learn from repetition. Look how long it took the guy to learn how to play checkers. It took him 40 years, or however long you said it took a lifetime, whereas it took the computer about 2-3 weeks. I agree, a computer program is only going to be good, or a computer is going to think as well as the program that is written that it's following. A computer doesn't really think, it executes. It executes the instructions that are written. And however good those instructions are, and the little sub-programs, the subroutines that it branches off to go find to solve maybe one little block of a problem that it's already got a subroutine that is valid for that bit. But that's kind of what we do. We learn we learn through repetition. It takes us a long time to learn stuff.
Gentleman down here.
Kind of in the same context as what he was just saying. If you look at a checkers game, the world that you're looking.
There for some purpose.
Okay, I'm sure it's close enough. The world that you're looking at is a two-dimensional board with a very limited number of things that have to be decided upon, and the sensory input that whatever's making the decision is very limited. So you can write a program to do that, and I think to think. if you could get a computer and you could have enough input to it where the inputs that it was getting was as complex and was quantized as much as what the human body gets and the human brain gets, then I think potentially you could write a program that could think. But you know, what you're trying to do is compare a two-dimensional case, whether it's chess or checkers, something that's very limited, to a human that has, you know, think of all the input, how it gets to the brain, whether it's touch, feel, hearing, you know, and it just goes to infinitum, to all the way that information gets into to the human brain. So if you were writing a computer program to simulate that, the way it's going to make all the decisions, if you could quantize every bit of type of information that comes into the human brain in some way that you could put a number on that to do a comparison, then sure, you could write a program to do that. Now, will that happen in the next 10, 15, 100 years? I don't know, but I don't think so. But I think it's certainly possible.
Thank you.
I took a look at, you know, rather than answering the question right straight out, does a computer think? I sort of said, what is thinking? And, you know, to me, thinking is, can I pose a question? And why do I pose a question? And the questions that I pose are based on needs. Now, what does a computer need? A computer doesn't really need anything. So I don't think that a computer, based on that premise, is going to be able to think, because it's not going to be able to pose the questions that will cause it to search for answers.
Doesn't it pose the question in checkers, what move do I make?
No, I think that it needs a stimulus, and that stimulus, yes, and my stimulus is based on my needs. A computer doesn't, okay, a computer doesn't have that initial stimulus unless I give it to that computer. And to me, that is whether a computer thinks or not.
You're
Does it?
familiar with the experiments we've done on humans which deprive them of sensory material.
No, I'm
You
not.
don't stimulate them at all for a long while. Leave them floating in a tank of water with no stimuli. And they, after a while, don't do very much with no stimuli.
Don't they turn into primal apes or something like that?
Something like that.
Wasn't that a movie?
Another point that I kind of took this a little further, I said, as far as limits, I think that as a human, I realize that I have limits, but does a computer realize that it has limits itself? And if it does have limits, if it has self-realization, then
You were talking about self-awareness.
self-awareness, exactly. And I don't think a computer has that, or nor will it have that capability. He mentioned, you know, thousands of inputs and stimulus to a computer, but I don't think it's going to pose that question, or it's going to be able to place value on certain self-aware things.
Somebody else wants to get involved?
I think you mentioned something a little bit ago about thinking creatively. I'm not going to go quite down that line, but I think one of the things the computer does is it operates within whatever paradigms that the computer programmer has given it. And to be able to operate outside of those paradigms, I don't believe a computer can do, and that's one thing that humans can creatively do. For instance, Einstein's discovery of the theory of relativity was operating outside of a Newtonian paradigm. Could a computer be programmed to creatively, if you want to use that word, think outside of the paradigm that was given to it?
Give you a simple observation. You were born with a small gizmo in your head to learn language. The language you learned was the language you heard from the environment. You did not learn any other language until you got books in the environment. You only learned what was around. You learned from the environment. What the environment didn't supply, you couldn't learn. Right? You learned, whatever country you were born in, each one you first learned to speak that language, arbitrarily from the environment completely.
I agree. I'm not following where you're going with it, though.
I'm merely saying, everything you learned from your environment too, like the machine does. It's all put in you. If you believe that stuff.
I'm not sure I do.
It's not my problem to believe. It's yours. Yes, sir.
Regards to the question of whether machines can think or not, I don't know. But the question I ask is, do we want machines to think? And my answer to that would be no, because if machines think, then they may become just as unreliable as people, forming unions, traffic lights going off and on, whenever they wanted to, because after all, they would think and say, hey, I am bored with this. I no longer want to be a traffic light. I would rather be a microwave or something like that. So I think we're actually heading in the wrong direction as to, coming up with some idea that let's make machines think. What we want is to be able to control machines and not allow them to think.
He has a very good point that all the early machines were designed to do what we wanted. But that's not what the people are trying to do, get machines to think in artificial intelligence. They want to get the machine to produce things we cannot. And the question is, can they in the long run? Some more comments? Okay, one over here, fine. I don't want to deprive everybody of their time on the air.
Yes, sir. I approached it similar to the young man up in the front row with trying to define thought in the first place. I figured that thought more or less evolved as a survival tool, and it's more or less a procedure where you start off with a perception of an environment, you anticipate a change in that environment, and then you derive an appropriate behavior to account for that change. This requires, obviously, first of all, the ability to sense the environment, to recognize a pattern that you can predict what's going to happen, develop an appropriate response, and either execute or at least output that response. So I think of thinking as more or less a continuum of abilities. We all know, if we've got kids, or we've all had people who worked for us or we worked for, who looked at the guy and just said, that person is not thinking. Okay, which it wasn't showing the ability to think that we would see out of, say, a gun director. However, we've also seen people with the ability to think on a level we could never approach. And I think that the different levels of that are based on either, in terms of sensing the environment, the ability to imagine or create an internal environment within which you're operating, which can be very abstract, the ability to recognize different complexities of patterns, the likelihood of success of your reaction to whatever you anticipate being the result of those patterns, and the ability to effectively come up with a response to that. So there's really, if the bottom line answer is the way I've defined thought, yes, a machine can think. It can, say, a missile guidance system can sense a missile coming in. It can anticipate where it thinks the missile is going to go, and it can develop an appropriate reaction. But that is not necessarily the same. That same machine then would not necessarily be able to come up with a theory of relativity, because it doesn't have the sensory inputs, etc., to achieve that.
Since the subject of relativity and creativity has come up that way, let me tell you, I've made a long study of these matters. I've talked to people who've done creative, and I've examined myself how it happens. When you look closely, you find that the person is led inch by inch by inch by inch to the result. It isn't suddenly, although in some extent it is, when you look further you see, oh yes, that reminds me of something I did earlier, yes, that's my subconscious generating up something that I had remembered from earlier times. Most of the time you can see things. For example, in Einstein's case, as a child he had asked himself the question, if I go with the velocity of light, what will a light wave look like? Well, it would look like we're standing still. But he knew that the formulas for light do not permit a stationary maximum. So he knew as a child that there's something wrong with the velocity of light. If you could move that fast, you'd see things which said you couldn't see. Now, is it surprising he finally comes up with something where the velocity of light is limiting and relativity is what it is? He laid down the steps by asking questions earlier, inch by inch by inch, until he was led more or less to it by the hand. That's how almost all creative work occurs when you look at it. It's true you wake up in the morning and suddenly you see it. But when you stop and examine, how is it that you saw that? oh, well, that's like something I did in graduate school, or that's like something I saw over there. Creativity is not that light bulb going on that you see in a comic strip. It's much more slow development, and much of it goes on in the subconscious until finally the moment of consciousness occurs. But that doesn't mean that there wasn't a slow, steady thing, and various elements cause the thing, and you could argue, serious with relativity, that there was no thing between step by step by step by step, cause, effect, and he was led to it by chance. Anybody that want to talk about things? Yes, back in the corner over here.
I want to follow up on what I said before. I tried to make the point of how limited the environment is that the computer is thinking in. And I said the chessboard game is very limited. There's a limited number of options, a limited number of inputs. And so if you were a person and that was your world, would you be thinking? And I believe that the computer, the chessboard game, does think in its environment of the chess game. I compare that to the fish I have at home in a little fish tank. Does that fish that's in there swimming around, does he think? Does he make choices about what to do in his fishbowl? And I believe that he does. Now, is he limited like the chess computer program? He is. His brain is much more limited than the human brain. And the joke that goes along with that is one fish says to the other, "Is there a God?" And the other fish says, "Well, yeah, there must be, because every week somebody changes the water." So, what a dick.
Anyone else want to talk? I'll go back to the list if somebody doesn't want to talk. Yes.
I also asked the question about what is thought, what is the definition of thought, and when people are just sitting there daydreaming, are they not thinking? I believe they are, and I don't think computers are able to daydream. So if you have a broad general definition of thinking, which includes daydreaming, imagining, I don't think they can do it.
You would suggest I can't write a program which will daydream? Or you suggest you can't?
But if you do, it doesn't produce any results.
Can you write a program
So you don't.
that causes a machine to daydream?
No. You cannot prove that it's daydreaming. You can't prove that it's
You
doing
can't prove
anything
you are either.
because there's no
Machines
results.
have daydreaming.
I can prove that I'm daydreaming based on the emotions that I'm feeling from it.
Why should I believe you? Okay. Yes, sir.
And talking about this whole idea of what is thought, which really is kind of a critical issue in this discussion, obviously. One guy talked about, well, do we want computers that can think? And he said, no, they might do crazy things. I thought, well, that's kind of ridiculous. Then I thought and said, well, perhaps you could define thinking as the ability to deviate from the standard program or paradigm you had. So I thought, well, maybe it's not such a ridiculous thing. So could we possibly define a computer to be thinking if it somehow has deviated from its original programming? Hard to imagine, because you'd think that that deviation in itself was somehow programmed into the computer. Which also then brings us back to people and saying, are we really thinking? When we do something that seems to violate the rules that we've always followed in our life, is that very deviation something that is somehow programmed into us at a deeper level? So am I answering the question? No. I think it's a very circular argument and a very, very difficult issue for that reason.
Anybody else? Yes, sir. Oh, did you want one? Oh, he was. You're on the air.
I know the professor hates this, but when I started looking at this, I had to go to the dictionary. And it said that thinking was to exercise the powers of judgment, conception, or inference. Now, I'm not going to argue the judgment part or the inference part, because with any established set of rules, you could say a computer, operates on the judgment via the rules that are given to it. And I wouldn't argue the point on people, the circular argument of people operating by an established set of rules or not operating by an established set of rules. You can always say that there's a set of rules that they're operating by that they don't realize. But that's where I want to get into thinking and the exercise of conception, the word concept. Computers, when they're operating by their set of rules, they load the rule into the CPU, they do the instruction. They know the rule, they do the instruction. They go do the branch, they do the instruction. You can say that I operate by a set, of standard rules, but I will also say that I don't personally always understand what those rules are. There have been times where I'm driving on the highway, why am I doing 60 miles an hour as opposed to 58 miles an hour? I don't know. You can say there's an established set of rules that are causing me to do that, but I don't understand why. The removal from the rules can be considered concept. When you say he's got the general concept, he knows what's going on, he or she knows what's going on, but they don't necessarily know all of the rules. An example for your fish is my dog. I taught my dog how to sit. I taught him how to sit in the living room. But when we go outside and I say sit, he sits. He has the general concept. He ignored some of the rules. He may have said to himself, I'm not in the living room anymore, so I better not sit down, because that's not part of the rules. Whereas a computer, if you're loading the instructions in, its set of rules are a set of rules, and it knows the rules. Whereas concept, you just need the general idea.
Yes, sir.
Yeah, when we look at rules, there's a couple of different ways of looking at them. Just since I've been here, I've looked at neural networks and genetic algorithms. And when we talk about the set of rules by which you operate, I've heard that NASA, for instance, is using a type of neural net, backpropagation neural net, that they teach to be a flight controller. So they have an aircraft, they put it through its paces, and the flight controller learns that if the pilot puts the stick over to the right, then you better move the ailerons like so and make the plane go to the right. So that's fine. So apparently, in about 2 weeks, they can train it to handle the nonlinear case of flight dynamics, and if the scientists or the engineers themselves are building, it might take them 6 months. So that's a good thing. So that's a machine, a computer that's learning, and is it thinking? Perhaps it is. What's more extraordinary is, in this case, apparently they've done some experiments, simulations where, for instance, a fighter jet, they blow a part of the wing off. Now no longer, if it was just a hardwired controller that an engineer had built, no longer would just moving the stick so much would that make a difference. But because of the way that this machine continues to learn, it's able to adapt to the new circumstances. It can now control the aircraft in a matter of seconds or less. It relearns the new environment, whether it's now outside, but it's still supposed to keep the plane flying. And the pilot, the human thinking guy, can just continue to do what he does best, put the stick to the little bit to the right and a little bit to the left, because he couldn't have learned to control the aircraft in the time that the machine did. So that's a case of an algorithm implemented, a computer that has the right sensory input, is able to adapt, and can think out the solution to keep the aircraft in the sky.
Thank you. Anyone want to talk anymore, or are you flattered? Yes, sir.
Let me just make an attempt to build a small bridge here. I believe that machines can think, Marines can think. Right, exactly. What Marines are, man, now you got me doing it. What machines cannot do is feel, and if a chess program beats a human competitor, is that machine glad that it won? Can it feel happy, in its victory and that sort of thing? And that's a small bridge that goes across there. machines, Einstein's theory of relativity has been referred to several times. Einstein did not invent relativity. It was always there. Einstein finally, through application of what he knew, finally developed the correct sequence of events, the correct sequence of equations that he could define relativity, or he could explain it. I think it's a little dangerous to only define something that terrific as thinking. Every time you go home and do a homework or work out a problem, you obviously, by most people's definition, are thinking, and that's just a standard application of what you know and what you've been exposed to solving a problem. A machine is no different.
I too looked at the idea of what exactly was thinking, and I came up with kind of a broad definition. I like the term intelligence better than thinking, because in my mind I think thinking is a very lower level of intelligence, a very broad form of intelligence. I said just right down to the basics. Something that makes something begin to be intelligent is just being aware of its surroundings. Can a computer be aware of its surroundings? Yes, I believe it can. You can easily develop sensors that allows a computer to know any of the 5 senses that you have. Okay. Then above that I say thinking. Okay, thinking is actually being able to take those senses and being able to logically put them into some sort of result, be able to compute something. And that's all just based on your input. And I think a computer can definitely take input and give some kind of output. Granted, that's based on how you program the computer to do it, but the computer's still doing it. It's still computing. So it's, in my mind, it's thinking. Now above that I say there's a certain thing called, for lack of a better term, I just said being smart. And I liken this to something, you probably all know the individual that can go up to the chalkboard, probably do a triple integral on the back of his head, but the same person probably doesn't have the common sense of screwing a light bulb. Okay? This person is smart in the field of mathematics, but he lacks the common sense or the ability to reason out how a light bulb actually works. He can't explain what he's doing, he just does it. Okay? And then there's common sense. This is the guy that doesn't know the intricate details, but he can screw in the light bulb, he can take things and he can put them together, he can relate two things together and make something work. Okay? And then above all this is just somebody that's just intelligent. And overall intelligence is the sum of all these things, being able to relate one thing to another, being able to look at the broad picture and then zero in on the specifics. Currently, I think computers probably lack that ability because we're limited in the way we program them. Okay, you know, it's like garbage in, garbage out. You hear that about computers all the time. If we're not programming them to have complete recognition of the surroundings and to be able to relate all the surroundings, then it's really our fault. It's not the computer's fault. You know, the computer is like sitting there, in my mind, just is waiting for the ability to come, for us to be able to program them. I looked at another aspect of this question too, and that's the arrogance and even of man to ask this kind of a question. Because I'm looking at, you know, for a long time, man thought that he was a supreme being over everybody. Not only all animals and everything of the earth, but also other men. Okay? One man was better than another because this one race was stupid or they were uncultured. Okay? I would like to think that our society has come closer to being able to resolve those conflicts. Well, then man thought, well, I'm supreme over all animals. Well, we know now that there's a lot of animals that obviously think. Okay? We don't hold all the cards on thinking when it comes to animals. And I just think we're at the same question with the computer now. Man doesn't want to give up that right or that supremacy over a machine. You know, we don't want to be able to concede and say, yeah, the computer can think. Because once we do that, then what's left for us to be supreme over?
Speaking of this thing, right? Listening to some of the dialogues here, or some of the statements, I think that thinking itself is related to a broader issue, or broader issues, and I would say good and evil. We consider computers or machines being devices or tools that we use either for our benefit or if we want to use them to harm other people. I think in that connectivity, as I think Mike was saying, we can't program feelings into the machines. The machines can't then reproduce machines of their own to do the same benefit or harm to others. At least, and not to the scope that humans can. I think humans possess that and can't yield that to anything else. I think that's what makes us unique. The capacity really to love and to hate.
I hate to bring this up, but there was a robot that killed a person. So robots are pretty good, like humans. If I gave a machine more senses than you have, would it not be able to do more? There's been some talk around here about the machine not having all the richness of input that you have. Suppose I build a machine with more sense organs than you have, and as the gentleman in the corner talked about, turn it loose on a neural network which can learn from experience. Would it not now have a richer environment and do better than you?
Yeah, kill off all the people.
Yeah. Might be. By the way, machines are now designing chips for other machines. The Pentium chip and all the other ones were designed basically by a machine. The humans gave some direction, but the bulk of the design was through the machine because no human mind could have looked at the millions of connections between all the components. Machines do design machines, and machines can design better machines than the ones they are doing the designing. And we're assembling machines by machines. So I'm not sure machines can't make better machines than themselves.
Well, is that
tasking? Hold it. You got to talk to the microphone. The rest of the world is entitled to it too.
Well, machines making other machines, is that is that tasking, or is that just is that reproducibility? I mean, when we have a machine making another machine, we know the characteristics that go into the product. When humans make other humans, we've got things going in that baby that no one knows from generations ago that may have come up. So I mean, that's the difference, I think.
Well, I can program that in if you wanted it. It's been agreed. It's been agreed by and large. We have wanted in the past machines that did just what we wanted. It isn't that we could not program machines to be random. They could wait until cosmic ray came by and then do something, or not. We can easily fix up machines to be random if you want. We have always, up to now practically, wanted machines that did what we wanted them to do. We want a gun director to shoot down that airplane. We don't want to go out and play checkers. Anybody else want to talk? Yes, sir.
How do you program a machine with morality? Because everyone, asks people what's moral in this room, I bet you get the same number of answers as there are people in the room. So, how do you do something like that? I don't have the answer.
Just need a little more room here. I looked at this question for can computers think, and I first said, well, how do I think? How do I do it myself? And if you just look at your body in general, all you are is a biological engine. You've got DNA that executes its code and that makes the processes inside your mind happen. And somewhere above all that, I think, is where thought comes from, and that's how I think. So I looked at a computer and said, well, what does it do? It's got a microprocessor, it's got memory, it's got little bitty instructions going in there making everything happen to it. That's just like the best parallel I could come up with is the DNA happening inside of me. So you can say a program, if you kind of define how you're going to define thinking, you can say that it's thinking on a very, very primitive level, and maybe that's what I do on a very primitive level. You start taking your programs, though, you've got things now like object-oriented programming in C language, where you're creating an object that reacts to other objects. But that's just part of a program inside the machine. So I'm thinking that where computers are going is you're going to see programs that, yeah, that's just executing the instruction down at the microprocessor level. But above that, you've got another level where you've got an object that was created inside the machine talking to other objects also inside the machine. And pretty soon you probably have other machines all talking to each other, and you got objects everywhere, and they're reacting to each other. But what it comes down to is I don't think you can apply your standards of thinking to a computer because you think in one particular direction and everybody thinks in different directions. And a computer is going to think in its own direction, and it's going to have a completely different way of thought. To say it's got feelings and all that kind of stuff isn't going to apply in its world because it doesn't know that. It might have its own definition of what a feeling is, and that's what it's going to go and do. So I think morality and creative thought and all that kind of stuff and intuition are things you're applying to your world and the way you think, and that a computer will have its completely own definitions for that when it comes to that. Next. Yeah, Walt's going to answer me.
Actually, I was going to answer Stu. I think the morality issue is really an interesting one for a computer, because if you think of a computer works in pretty much a black and white environment. With humans, it's not that way. All of us in this room can broadly define our own morality. But how many of us can actually say that we live by a strict set of morality rules? Okay? When is it okay to break the rules? Okay, we make those judgments. With a computer, you wouldn't do that. If the computer was operating your car and the computer said, hey, I'm driving on a stretch of highway, the speed limit is 55, the computer's going to drive 55. Because it doesn't have the capacity to say, well, it's okay, I don't think there's a cop around, so I'm going to speed. I mean, you could program that in. You could say, well, if I don't detect any radar guns in the area, then, okay, I'll go 10 miles over the speed limit or 20. But I guess the point is that on the issue of morality, it's almost as if a computer is one up on us because they can formulate a strict set of rules that they are going to be forced to follow. And then the flip side of that is that that they're below us because they don't have the judgment to be able to say, when is it okay to kill? Okay? Can you kill somebody and justify it if you're protecting yourself or protecting somebody else? Well, there again, you could program that into a computer. I think an interesting thing to do would be for each person to write his own computer program on his own morality and go to the issues of stealing. Write an if-then lib. If this is happening, then it's okay for me to steal. You know, all the way down to else don't. Same thing with every issue of morality you can think of. I think it'd be an interesting thing for each individual to do.
Okay, when I looked at this question, I think the first thing I did is try to define an environment in which we should ask this question. You know, essentially the testing environment. I thought that if we compare a human with, you know, what we've learned through our life experience with a computer programmed with human, well, that would give us the wrong answer. Essentially, you're biasing the whole issue because you're asking a human to program a computer. So I think the test is really to look at what a computer can learn and do on its own by using, you know, any kind of either existing or even what we can foresee in terms of algorithm, like learning algorithm, like what Ian talked about, neural networks, genetic algorithms, and all that. And I think then I looked at the result of, you know, we have this computer, assuming that he has the same or even better sensory perceptors, I guess, that we have, and see what it can do. And I guess the easy, for me, anyways, answer that I gave myself was that the computer can be very, very good at acquiring information. You know, it can learn all kinds of things from what it can see. But what it can't do is acquire understanding of what it sees. Okay, that's where I feel that humans are better than computers and will remain better than computers for, you know, the foreseeable future. When we see something, we don't only, you know, if you see a ball fall on the floor, you can't calculate the formula exactly. The computer, if, you know, with the proper program, proper perceptors, can look at it and say, okay, this is the equation of the falling ball. Okay, I have it. But the computer won't ask why. Okay, so I think what it comes up to is that humans, because of feelings and everything else that makes us, because we are motivated to always ask, well, why is it doing this? And that's why we, you know, since the beginning of time, we've
evolved. We've found things that were not in our environment. That, you know, I think even Einstein, a lot of the theories and all that about, you know, astrophysics or whatever were all from humans based on things that we cannot observe. I think computers, if you could have, you know, observed an experiment with, you know, E equals mc squared, they would have found the end. You know, they would have found the formula, but they can't come up with the why.
Yeah, the issue, of course, is thinking, but the question I would have is, are computers really thinking like the chess programs, or are they simulating the thinking? I think that's coming up before, whereas we have a chess master and is thinking maybe 100 moves down the road, can defeat a computer who's thinking of moves a million times a second. So what is there different in the chess master that allows him to beat a computer? Well, perhaps the chess master is thinking on some different level than the computer is crunching numbers, which is really what a computer does. So, you know, we can look at it, we can do programs that kind of simulate the thinking, but really it's a computer crunching numbers. So maybe the question would be, could somebody write a program for a computer to answer the question, can a computer think? Well, yes, you could probably write a program and he could discuss that, but it wouldn't be the computer discussing it, it would be the programmer.
He spoke of simulating intelligence. I would say there are frequently times when the teacher feels the class is only simulating intelligence. Any more? Yes, sir.
If a computer, let me see if I can get this right. Right now we have computers that are designing computers. Let's look down the road. Maybe we can see it coming, maybe we can't. But what's to stop a computer from finally learning to write its own programs? Here we are talking, well, right now we control the computer. We write the programs and we keep it within our bounds. Well, I mean, look at the caveman and look at even beyond as man evolved. Man didn't know very much lots of years ago. But over the years, it's evolved, or we've evolved, and we've become what we are now. Well, it's been demonstrated that computers can do it a lot faster. Learn that it, well, if you take the checkers game and call that learning, you know, maybe on the most primitive step. But what's to stop if once a computer can say, well, can write a code all by itself, compile it, and learn that way? You know, I mean, we are applying our set of learning rules to the computer, whereas maybe the computer has its own set of learning rules, and once we might be right now at too low a level to see it, but it could break through the barrier to where it'll write its own programs and figure out things the way it needs to. It takes its own subroutines or whatever as it needs it to solve whatever problem you give it. You know, who's to say, and maybe it'll take 1,000 years or whatever, but who's to say it won't happen?
Anyone else? Well, it's getting near the end of the time. Let me say that I am pleasantly surprised how well you've done on the average, and I congratulate you those who spoke, and those who kept quiet, I don't congratulate. Let's quit for today, and we'll resume Friday on n-dimensional space.